I've been buying gas cylinders from the scrapyard, and they all have odd fittings on them, CGA 320, whatever. And especially these, the actual valve to cylinder fittings are odd ones that I don't have the ability to make. But on this one, I can remove this pressure gauge and I can make a flange using a washer and a pipe to bolt onto there. And this can first be a gaseous oxygen tank, and then eventually I could convert it to being a liquid oxygen tank. But I would need to add some ports on the top, or run a tube from below to the top. Now I know this thing holds pressure because whenever I opened this up it had about 10 psi of gas in it, and it spewed out, gave me quite a scare. But it was only a little bit of remnant of propane left over. I've had it open for a while now, and so hopefully it would have kind of leaked out. So we shouldn't have too much of an explosion risk. I will be filling this up with water and then draining it to make sure all the propane is out whenever I go to actually put pure oxygen in there, because I don't want to kill myself. So I made this, which is a scratch outline. So I can go ahead and drill the holes. This will go like that. Pushing it a bit close, but I think it'll be fine. Which this is just some washer that I had from some like ring toss thing. Found them at the scrapyard. Oh no, I found them in that barn in 2017. That's what it was. And so I'm going to put this down on a piece of sandpaper, on a piece of glass, to make sure that this is nice and flat. And I noticed that this is uneven as well, has the machine marks. So I might go ahead and do the same thing for that, or I'll take a piece of glass, put a sandpaper around it, and then carve that nice and smooth. I guess the term is lapping it. Perfect. Well, that looks close. Very close. Oh, does that go through? No, it doesn't. Okay. That'd be quite dumb if these holes went all the way through into the tank. The threads are all corroded up or something on this, so I'm gonna try to tap it out or whatever the term is. Probably just gonna fuck it up. Actually, because it's like the threads change halfway down. It's weird. I've never used one of these before, but I don't know. Unless it was threaded on wrong at the factory, because it was stiff. I didn't think I forced it enough to really. Oh, this fucking cheap fucking tap and die set. Still bottoms out halfway down. I'll have to see what that's about. Yeah, that makes no sense. But now it goes in and it's nice and tight, so maybe I did clean it up, I don't know. I'm not a fan of aluminum, that's for sure. Wow, so it does fit, just only whenever it's lined up that way. If it's that way, it doesn't fit. If it's that way, it doesn't fit. If it's all the way around, it doesn't fit. It's only that way. So I guess these are kind of split apart more, like a trapezoidal shape or whatever the term is. But that's not really, that's not tight at all. That's good. So weird. It does make you wonder how these are made to such low tolerances. That's too much voltage. Why are you burning through? You're on the lowest setting. For fuck's sake. So it's not burning through. It's just burning the zinc on the inside, I guess. I don't know. Well, I guess we continue. I know it doesn't look like much, but that might be my best weld ever. Not just a garbage weld, but something actually consistent, a little bit at least. Whoa, look how straight I got that by eye. It's pretty good in my opinion. The washer is a bit offset, but oh well. Forgot how thick these darn pipes are. It's pretty thick. My carbide bit was broken, but I wanted to see if I could use the rest of it, and I did, so that's cool. Well, I guess these pains are meant to take that kind of abuse. Oh well. It is starting to get the machine marks out and make it really nice and smooth. So I got that pretty well sanded down. Not quite a mirror, but it's a difficult surface to get to. It definitely feels really smooth, so a gasket will fit onto that a lot better. The original gasket fit into here, but that doesn't quite work for this job. And I believe this used to be an O-ring, but it's been squished down to like a square shape, and plus it's cracking. Now as for the gasket that connects these two pieces together, by the way, that's a nice solid connection. Those are really well mated together. I'll probably go with silicone, just some silicone sealant, because I do not believe that silicone burns in oxygen. Some PTFE or Teflon or whatever would be nice, but I had another idea that's a little bit crazy. This lead sheeting that I have, it's really soft, but it's thick lead. I wonder if I could cut a square out of that, or a circle, and run it through some rollers or something, make it super smooth, and have a lead gasket. I imagine I have to really crank it down to squish it, so that probably won't be a good idea, but just an odd thought that passed my mind. For now, I will not be putting a gasket on there, because I'll want to clean this out, pressure wash the inside, make it really nice and sanitized, and I'll need to get a brush and clean out the insides of this, because there's the burnt zinc in there. But I just wanted to go over that. But the main part of fabricating this piece is done. I am a bit worried. You can see there that the pipe didn't get welded to the washer very well. There's still that seam. So it appears that only this side weld actually held up, because this one I thought I was welding too hot. Turns out I was welding okay. I turned down the voltage and that made it not weld as well. This mark over here is just from the lathe, so disregard that. If I ever make another piece it'll be better, but oh well. Now sadly I don't have any washers that'll really fit, but I do have these rusty nuts. I mean, oh well. So that's on there nice and solid now. Happy with that. God. Yeah, it's solid. I'm thinking I'll probably run this at 40 psi. And if I go above 40, we'll have to do an actual hydrostatic test where I fill it all with water, remove all the air, and then use a pressure washer. I have the adapter for it. I'll use a pressure washer to push liquid into it until it, well, passes or fails. But I'm happy with how well that mates with that surface. I'm really happy with that. And I'm glad these threads didn't get all fucked up. I'm not sure what was going on with this thing. It seems a little, I thought it'd be more standardized and more predictable than it was. But it seems like the holes weren't aligned correctly and all that kind of weird stuff. And then I can use this for something. I'll have to see. If I switch over to liquid oxygen after this, then I'll definitely have to make a new one of these out of stainless steel. At least I think I would, because I don't want to deal with liquid oxygen and used steel. But I'm doing this on such a low budget, I just don't have the money to really do that. And I don't have a TIG welder. I haven't learned how to weld stainless steel, and I haven't bought stainless steel and all that stuff. So for now, for gaseous oxygen, this will be fine, especially because I'm going to be working on making it even safer to where I have the valves to pressurize the system and possibly even to depressurize the system, all controlled by, well, maybe even controlled by computer. That would be pretty cool. And then I can also have the same data lines having and storing like pressure, like have some pressure sensors, like maybe remove that, put pressure sensor on there, or just on that, I don't know. I'm happy with that though. So this is going to be the smallest upgrade possible. This is effectively just going to be in line with the current oxygen input, because whenever I would trigger the engine to start, it would start off with a pop because it had 40 psi, but the poor little regulator, once I open that valve, that solenoid, the pressure just drops because it can't provide enough air, enough gas. And so really the engine was just running off of whatever, however much cubic inches of, or whatever of propane or oxygen were in the hose. Well, if I put more space in the hose and have more of a reservoir, so then that regulator fills up this, and then this is what gets discharged into the engine, it will not be consistent. It will still be like, or like 4 or 5 seconds, depending on how well I can get it to go into the engine. but it'll definitely be a lot better. I'm thinking this could be for the propane, since I'll need less propane than I need for oxygen, but there's still going to be a mismatch because this is what, 1/3 of the I don't actually know what the difference is, but this is like, I would imagine this would be like 1/3 of the volume of this. And so that means that as the two depressurize, the mixture of the engine, since it's unregulated, is going to change to where it'll get really good and then it'll get out of whack again as they both empty their contents into the engine. But we can always then add a regulator system after that to make this only output 40 psi, and then we could even experiment with upping this to 80 psi, something like that. If I go past 50 psi, I'm gonna do hydrostatic tests on these because they were at the scrapyard. This is like $20 in parts here. I don't trust $20 in parts with that kind of, well, actually I wouldn't trust any tank with it unless I pressure tested it. But I'm hoping that this can be a good chance for me to start digitizing a lot of the input and output. Last time I had just the 2 switches for oxygen and propane, and then I had the sparker running constantly. But this time I would like to have where the hinge on the regulators are electrically controlled. I want to have a pressure sensor inside there. I want to have like 5 or 6 different controls, and it'd be a lot better to have that run digitally and not a line for each thing, because it'll get too far out of hand. Plus then I could also have like temperature sensors, and I could have a lot of other things and actually get some data, and maybe even have it go into a computer so it charts it out. I'll have to figure out how to do that. I suck at that kind of thing, but I'm sure that I could use like an Arduino with an Ethernet cable or something, who knows. This is a CGA 230 or 320 fitting, and so that's about $10 to get an adapter from that to NPT, National Pipe Thread. So that'll be figured out. I do worry about the flashback preventers, or backflow preventers, flashback arresters. It's the one-way valve that in case fire goes back up through the tube, it'll stop and it won't blow up the tank. Now, of course, I'm going to be far enough away from these things that if they do blow up, it'll be scary, but it won't hurt anyone. But I still want to have one of those backflow preventer things on it. So I'm going to have the default ones from my torch on there, but I think that will limit the flow too much. So we'll see what we can do with one of those. I might be able to actually do 2 in parallel. I probably shouldn't. That's just too much work. I'm starting to learn a little more about machining, getting a little better at that, a little bit, slowly. And I might be able to actually make myself a larger flashback arrestor, backflow preventer thingamabob. And that would probably be the best route to go down. Make it like it out of copper or brass, and so it would have enough flow through it, like this large pipe, but it would also be very sensitive. So in case like pressure came back, it would lock. I might be able to even put that into the regulator. If I build like a regulator with a spring valve thingy, then I can have it to where it's like one unit that connects to each one. That would be pretty good. Well, I would like to hear what you guys think about what gaskets I should use. I think silicone would be easiest. If I can find Teflon, I'll go with Teflon. That's pretty much it. Good recommendations for how to digitize this system. For instance, have it wired into an Arduino that would be like I2C or some format talking to a computer. Now I'm hoping through a power cable, because a power cable has 3 pins. You can have positive and negative for power, and then you can have another data pin, which you could have like serial interface. We'll have to see about that though. I don't know. But it'd be really nice to have a way to see like a graph of the pressure or something. I'll have to look up like the cost of pressure sensors or whatever. For now though, I think my setup of just having two might work okay. We'll see. I hope you guys enjoyed this video, and thank you very much for watching. See ya.